So hello everyone, today we are solving LeetCode 19, which is remove nth node from end of a list. So this is one of the most frequently asked linked list interview questions. In linked list they always prefer to ask this kind of question or this question only. This kind of question possibly not, but yes, this question is very frequently asked in interviews. So yes, at first glance it looks simple, but the challenge is removing a node from the AND in just one traversal. This is the trick part, and by the end of this video you will understand not only the optimal solution but also why the two pointer technique works. So let's get started by understanding the problem as we do always. So yes, so this is the problem basically. So we are given the head of single linked list, and we have also have an integer n as an input, and our task is to remove the nth node from the end of the list. So if we have to remove 4, sorry my bad, so if we are given this list 1 2 3 4 5 and we are told that n is equals to 2, we have to remove, so we have to remove 1 2 4 is second from the last, second last, we have to remove this. So this is our task. So yeah, simple enough. The problem is simple, it looks simple, right? So what you can think of for a brute force solution? Let's come to the whiteboard. So yep, what you can think of for a brute force solution? What we can do is, first we can traverse the list, and we can find out that what is the number of nodes in this. It has number of nodes as 1 2 3 4 5. So yes, we can find the length is 5, and then what we can do is, then we have to the node from beginning will be L minus n plus 1, of course. Just check if the length is 5, and we have to delete n is equals to 2. So 5 minus 2 would be 3, but we have to delete this 4, so we have to delete plus 1 from it. So this would be the formula basically. So this would be brute force approach. We would have first traversed the list for finding the number of nodes, and then we can simply delete this from this 5 minus 2 plus 1. This is a simple formula, right? 5 minus 5 is the length, and is equals to 2 from the end, so from the start it will be plus 1 basically. So yeah, this is the brute force approach. We'll not focus on this much because it's a simple approach, and the complexity of it would be first traversal would be of n, of for loop or while loop, and the second traversal would be also an loop, so of n. So 2 loops of 2 into n, and we'll ignore the constant, so it will be of n basically, the time complexity, and the space complexity will be of 1 because we are not using a extra data structure. So yep, this was all about brute force. Now we will go to the optimal approach, which is the interesting part of this question. So observe, instead of counting the total length, what if we maintain a fixed distance between two pointers? What if we make 2 pointers, one pointing here, one pointing anywhere, on the elements? What if we maintain 2 pointers? Okay, we will not count, we will not do something. So if we have, I hope you have listened about the fast and slow pointer approach. We use it significantly for the middle of the linked list part, but yes, we will use it here. We can use it here. You will understand why and how. So yeah, suppose we have a fast pointer and a slow pointer. If fast always remains n nodes ahead, then when fast reaches the end, where will slow be? It will be exactly before the node we need to delete. Okay, you will understand, chill out. Yep, so optimal intuition is basically initially this is also here, they both are pointing to the first node. Okay, they both are pointing to the one node. This is slow, this is fast. Let me write, just a sec. What if we remove these and we write here, it's a slow, and we can write one more, this is fast. So you can understand from this. So fast is here also and slow is here also. Okay, so these 2 pointers are here. So what if we start moving? Initially fast and slow both are pointing to the dummy node before the head. So why dummy? We'll understand that shortly, of course, just wait. So first move fast n plus 1 steps ahead, since n is equals to 2, so we can move it with 3 steps basically. So like 1, 2 and 3. Fast is here. Okay, so we have two nodes in between them, and now we will like move both the pointers until the fast is null. So first what we did was we separated fast and slow between, like we separated fast and slow with the n is equals to 2, like the between them are two nodes, the distance is 2. So now after making the distance between them, then we will move them like together. So then we will move them together till they both get to the end. But yes, first the fast would go to the end. Okay, we will only move till the fast becomes null, because slow we need to, like we need that it reaches the node, it reaches before the node that we need to delete. So now we will move both the pointers, slow and fast, together till fast becomes null. So yes, fast is here now and slow also needs to move. So yes, slow is here now. Still fast is not null, it is pointing 5. Now we will move again, fast goes out and slow is here. So fast now becomes null, you know, right? Here it is null. Out of the linked list all the values are null. So yes, now it is pointing to null pointer fast, and slow is here. Where is slow? We need to delete n equals to 2 from the end, which is 4, and it is before the 4 value. It is before the node that we need to delete. So yes, this is perfect. So now slow is pointing at 3, next node is 4. So we will simply write like slow next will be equal to slow next next. We will just simply skip this 4 pointer and we will like, we do not need to delete it, but yes, it is simply deleting in a linked list because we are not pointing no longer to 4. We will point 3 directly to 5. It will automatically delete it. So this is the basic approach. Now we discuss the most important part. We made the dummy node here. Why we made the dummy node? When these, just a sec, when these fast and slow were here, then we would have like used the head to point these to the start of the linked list, right? But what we will do is we will have to use a dummy node. And why we use a dummy node? Consider that we only have n is equals to 1. For a moment, just think that we do not have these 2, 3, 4, 5. Just for a moment, remove these. Consider that we only have this one as a single node, and slow and fast are here, and we need to delete one itself. Okay, so what we are removing? We are removing head itself, and if we point slow and fast to the head, then what will happen? It will fail a test case, because if slow and fast are pointing to head and we need to delete head, then it will create a problem. Then we will not have anything to like point. So yes, there is no previous node before the head, so deletion becomes tricky. But with a dummy node, every node including the head always has a previous node. If we make a separate dummy node pointing to the head, then we would have a reference to head, of course. So yes, then we can like point slow and fast to a dummy node rather than pointing to the head itself. So this was the most important part. Okay. So yep, this was the like the dry run, or we can say the method that how we could do it. So now we'll move to the code part. Now we'll try to code it. So yep, just wait. Okay, so now we will try to code the question. So yep, what we discussed was the dummy node part. I hope it's clear to you why we are using the dummy node. It's just cause of this part. If we can, you can see this example too. These are the test cases that need the slow and fast pointer to not be pointed to head. It should be pointed to a dummy node because we should preserve. So yep. So first of all, we'll start with making the dummy node only. So we can make a new node. We can name it as dummy, and we can point it to anything. For now, we can like just say we can make it 0 to the, like we can make it 0. Now we will do the dummy next. Now can point to head. Now we will use this as a reference. Okay, so what we'll do now, we will start this okay, fast, and fast will be pointing to dummy now because we are using this. We're not using the head for reference, and slow will also be pointing to dummy. Why this is dummy next, you will understand. Just wait a minute, because like we will fix this thing when we are making the loop. So now what we will do, we'll traverse the the fast pointer till it like comes, like the distance between the slow and fast pointer becomes is equals to n, which is 2. So yep, we will start with we'll start moving it. So we moved it 3 times. No, we moved it 3 parts. So yep, from 0 to n it works, because if it is 2, so 0, 1 and 2, it moves 3 times. So yes, the distance will be 2. So like this it works, and we will, till then we will point this to fast, and fast would be next. We will move the fast pointer basically. So this is the moving part, and now when the distance is n between them, then till fast becomes null, or we can say, if we follow the latest pattern of C++, null pointer. So then what we will do, fast will move, and the slow will also move, because we need it. So slow will also move. Okay, so now when we reached this 3, so then what we will do is we'll point this 3 straight to 5. We'll skip 4. So basically slow next, what we will point it to, we'll point it to slow next, which is 5. So this is the basic idea. We successfully deleted 4. Okay. Yep. Okay. So now what we'll do is, finally we'll return dummy next, which was head. Yes, we are returning head only, but yes, we use dummy for it because it gives us better approach for these kind of test cases. So yeah, we will finally return this dummy next. So yeah, this should work fine. And for if we talk about the time complexity of this program, then what we are seeing is we have this loop and we have this loop also. So let's see. Yep, the complexity is of n only, because we are not having any nested loops or anything, and the space complexity is also of 1, because we are not using an extra data structure. Of course, we only use 2 pointers, and this was the nicest and best approach for this question. And yes, I think you were able to understand this. You will able to understand the proper intuition of how things work in linked list, and how these 2 pointers helped us to solve this question. So yep, biggest takeaway is not the deleting a node, it's learning the 2 pointer pattern. It is used in nth node from and, middle of linked list, cycle detection, intersection of list also it is used with the reverse pattern. And yep, in these kind of questions always think fast and slow pointers, and this is the most helpful pattern in linked list questions. So if this explanation helped you, consider subscribing the channel for more videos. I will see you in the next video. Till then, take care. Thank you.